So guys, this chapter here is we are looking at the original or the reasons for the bond. So we knew that we have pi bond, we have sigma bond, but we did not go through the details how those bonds are really formed, how single bonds are formed, how double bonds are formed, how triple bonds are formed. So from this point of view, we'll be more able to go through more more understanding of those bonds. And if you look at this, the Lewis did very well, very good job in the whisper and prediction of the polarity of a molecule, correct? And all the stuff Lewis they have done a very good approach of the whole thing. However, Lewis had failed um, in determining really the reason for this bonding, why sigma is formed, why is not by a double bond, by bond is formed. So Lewis had problems explaining to himself and to us why is this. Now, the about in the 60s, 50s, they come up with a lot of theory better than Lewis, and you can see that's this is, as you can see, this his theory cannot write one correct structure for many molecules. Resonance. Remember the resonance when the double bond migrates from one side to one side of the molecule, like the benzene ring. Lewis cannot really explain. But the good thing about Lewis is the Lewis dot structure is very essential, and the whisper method. He can determine whether the molecule is polar or non-polar, right? And determine the shape of the molecule. Now, the new theory here came with Pauling. Remember the Pauling exclusion of the valence electrons, the same person, the quantum mechanic. He postulated that the really the sigma bond, double bond, triple bond, all these bonds are orientation of the valence electrons in the very nice and very specific orientation with themselves, and so they can interact in their orbitals together. So a bond would not form if there is no interaction between those valence electrons, and it has to be their special alignment of those orbitals. So that's failed Lewis about as they are coming together and they align themselves, the orbital through the axis. So, and that's the difference between those two. But Lewis had a lot of contribution, as I said. So, valence bond theory, that's from the Pauling, same person who has a Pauling exclusion principle. So it says those orbital, they have the shape of S, B, D, F. Remember, S is spherical, D is dumbbell, P is dumbbell, D is dumbbell complex, and F dumbbell very, very complex. So the orbitals can spin around the nucleus in a spherical way, like the sun and the earth or other stars and other planets and meteoroids, or they can just go like this, dumbbell, and then finishing here and then go to Z axis and then go Y axis, and the nucleus will be in the middle. So the we can take advantage of those electrons found in those orbitals S, B, D, F. So and then we know those valence electrons found in this. Next step is to get the correct alignment. So if this is an atom moving like this, correct, the other one like this, so they come one time, one side, we call it side to side interaction, side to side interaction, or side to side overlap, side to side overlap. This side to side overlap makes sigma bond. See here, they come like this. So they come to one time, aligned in the same way. See, that will be your sigma. That will be your sigma. So it depends how they they come, what alignment they have. So the shape of the molecule is determined by the geometry of the interacting orbitals, correct? Chemical bond results when these atomic orbitals interact. There is a total of 2 electrons in the new molecular orbital. That's we know from Pauli. All orbital cannot have more than 2 at the time, correct? More than 2 at the time. So the P maximum of the P orbitals has suborbitals, correct? Px, Py, Bz. The Px, Py, Z, they have maximum each 2 orbitals. So the orbital interaction, again, you have to have an excellent alignment between them. And when they come together, when they come and mix together, so their potential energy has to be lower. So they don't come with a lot of energy, so they will be repelling each other. So they have to come up with lower potential energy here. So when they come and then when they separate, it's totally different from when they come together. When they come, their potential energy is lower. So the molecular orbitals would be more stable than the separate atomic orbitals. So this is understood. If you have an orbital by itself and valence electrons in the space by themselves, they can move around anywhere they want. But when they come and then start interacting with the adjacent neighboring orbitals, side to side, I mean, horizontal or vertical, correct? They can act vertically, those orbitals like this way, interact together, orbitals vertically, or they can horizontally, side this way here. So this interaction between those orbitals makes the molecule more stable, makes them what? More stable. So let's look at this. We speak about hybridization. So what is hybridization? Hybridization, when the valence electrons, correct, have enough energy here. So what will have? Some of the valence electrons, correct? Some of the valence electrons found in the lower orbitals, in the s orbital, come and interact with the p orbital in the top. So it looks like this: s, p, d, and f. F is higher, correct? S closer to the nucleus, p, d, and f. So what's happened is, if you have an sp or interaction, means they are hybrid. They clone themselves. Hybridization means cloning. Means the s orbital will come and interact with the p orbital in the top of them. So there are valence electrons in both, found in both orbitals, in the s orbital and the p orbital. However, they will interact and start cloning themselves, hybridize themselves. Hybridization means cloning. So we have 3 types of cloning or hybrid. Hybrids means same thing, hybrid. Like you have a car can run by electricity or by gas, correct? So, and some buses can run by diesel or by natural gas methane. Did you see buses? I think most market buses are by natural gas methane, correct? And some old in the farms, you find them by diesel. So those called hybrid. Means the engine is cloned. So the engine can work for a diesel or can work as natural gas methane, either or. And the same thing with the orbitals. They can, the s orbital, the top of them, the p orbital, they can come and clone themselves in 3 ways: sp3, sp2, sp. So how many hybrids we have? 3. Now, do we have more than that? Yes, we have sp3, sp3d, sp3, d2. So how many? We have 5 hybridization. sp, sp3, correct? sp, sp2, sp3, and then sp3d, sp3d2, correct? So in the PowerPoints, I did not find the sp3d D or D2 hybrid, but it's not really difficult. So how we, because this is S, B, and then D, they clone themselves together. So let's look at the cloning, the hybrid, making hybrid between sp3, how to make sp3. So we have here a carbon, correct? Carbon has valence electrons, group number 4, it has to have 4, correct? And those 4, 2 of them here, just write it here, guys. Those are 2 in 2p and 2 in 2s. So the 2s is lower in energy, and 2 in 2s. So that's the way, the correct way. We have to write that the 2s is coupled, correct? Counterclockwise and clockwise. The 2b are clockwise. So if I want to make sp, then I have to take one of those here up and put it here. Put this one here, take it out, and put it up. That's pre-cloning. That's pre-cloning. So I took one of the S. I have in the S, I have only what? I have only one electron, correct? And the 3 on the p orbital. So now I will clone them together. I clone them together here. I have a set of, so remember, this one here came in from the P after the cloning, and this one is left in the S. So S, P, how many of them? 1, 2, 3. So this is S, P, 3. Correct, guys? So how about I want to make SP2? Somebody will help me with that. So this is SP3. We know it's one of them is out, up to fill the third one, correct? So then I clone those 3. S has 1, and then P has 3, so SP3. Now, how about looking at the whole picture now? How about if I can make out of this one here SB2? Somebody will help me? SB2. So SB2 meaning what? SB and 2. So I need 1 from here and 2 from here, correct? So the 2R is already here. The 2 is here. I don't have to bother. This one is bothering us a little bit. So we'll kick it out all the way to the top. To where? To the D. This one can sit here. Are you following me here? So I took it out all the way out. I'm not interested in you. I'm not cloning you. I'm not making any pre-cloning or pre-hybridization to you. So you are out. So then I have what? I have one here S, and 2 from the P. So I have what? SB2 plus, I will say not D, I can put it here. I can put it somewhere. I will say another P here. That's why here it is. But I'm not cloning it. I'll keep it here, but I'll see. This is SB2 plus unused what? B. This one here, BZ. I kept it, and I can put it in D, but I can keep it for BC, for example. I can keep it like this. So this is SP2. That's 2, by the way. So this is 2 plus BZ. Are you following me here? So how about doing the SB? What should I do? Just SB. So I have to make will be what? Will be 2BZ, correct? So SB plus 2BZ, or say BX, BY, not 2 here. Just take the 2 out here. BX. Take the Y out. So take the Y out. So you can cloning and you can do a lot of stuff. I'll stop here. Attendance sheet, guys. Attendance sheet. So I'll talk to you then in Monday. And don't forget the quiz number 3 and exam number 3 will be due on October 31st. So I give you plenty of time to do, correct? So it will be due October 31st. That's a Halloween day. I'll talk to you then.